Hey there, Miss Sam's here with our quadratic functions with the Pythagorean theorem. So if you need to pause this video, stop this video, and watch one of the Pythagorean theorem videos before, we really dive into this, because we definitely need to make sure that we are sound on the Pythagorean theorem skill, finding that missing side length before we throw the Pythagorean theorem into quadratic functions or quadratic functions into the Pythagorean theorem. So we do know that the Pythagorean theorem deals with right triangles and you're finding your missing side length. So very similar concept whenever we're dealing with the problems today. However, you're going to see that there's going to be quadratic functions in it. So let's go ahead and dive in. And every single one of these slides, I have the Pythagorean theorem off to the corner just so you can see it. We can definitely be more familiar with what the Pythagorean theorem is. So think I'm talking too fast, I'm gonna slow down, and then let's really dive into this problem. So I start off with a visual just so we can see kind of what our word problems today are going to be looking like, or starting off with a visual example. So remember, C is always the hypotenuse. It's always directly across from that 90-degree angle. C, okay, and then we can interchange or intermix or switch out A and B because those are the legs. And because we are adding, doesn't necessarily matter the order in which we write them, but C always has to be the hypotenuse, which is directly across from that 90-degree angle. Okay, so we have A squared plus B squared is equal to C squared. I'm going to write that down. So A squared plus B squared is equal to C squared. Okay, I'm going to use 4 squared as A, so 4 is A, 4 squared. And then the whole base is going to be x minus 6 squared, and then C has the letter x on it, so that's x squared. Okay, so now let's really dive into what this means. So we have 4 squared, which we know is 4 times 4. Okay, that number is 16. And then we have x minus 2 times x minus 2, and then that is equal to x squared. Okay, so the piece on the middle there, where we're doing x minus 2 times x minus 2, you guys are welcome to use FOIL if you would like to, or you could use the area model / box model, whatever you want to call it there. Okay, that is not a straight line, y'all. I'm so sorry. Okay, I'm going to go ahead and use the box model just because, again, I'm a visual person, and I tend to like that method better. So x, we're going to have minus 2 for negative 2, x minus 2. So x squared, negative 2x, negative 2x, and then a positive 4. Okay, so what do we have now? We have 16. We have x squared, I'm pulling it from my box, negative 2x. Negative 2x is going to give me a negative 4x plus 4, and then that is equal to x squared. Okay, combining like terms, bear with me. We have 16 plus 4, that's going to give us 20. So x squared minus 4x plus 20 is equal to x squared. Now remember, my particular equations need to be equal to 0. Okay, so I'm going to subtract this x squared over, subtract this x squared, and yes, indeed, they do cancel on both sides. So negative 4x plus 20 is equal to 0. Okay, so we're definitely just looking at that part. So all of that is all the work. Now, if I gave you this 2-step equation, you definitely should be able to handle solving this equation. So what is the opposite of adding 20? Subtracting 20. There you go. So we have negative 4x is equal to negative 20. Divide by negative 4, divide by negative 4. So x is equal to 5. Okay, so I'm going to plug in my given information into my triangle up here. Okay, so x is equal to 5. This is 4. B is x minus 2. So 5 minus 2 is equal to 3. So your side lengths are 5, 4, and 3. Okay, so we really didn't see the quadratic function in this particular problem, but we did have x squared, and we had a whole bunch of combining like terms. We had FOIL, so you have quadratic function concepts now being thrown in to the Pythagorean theorem. Okay, let's check out another problem. One leg of a right triangle is 7 more than the other leg. The hypotenuse is 8 more than the shorter leg. Okay, so here is what that particular, all those words looks like. Okay, so we have a leg. Okay, the leg of a right triangle is 7 more than the other leg. Okay, so we already know that the other leg has to be the shortest one because the longest side is always C. The hypotenuse is 8 more than the shorter leg. So if one is 7 more, this is the shorter. 7 more, this always, remember, has to be the hypotenuse because it's directly across from the 90-degree angle and it's the longest side. Okay, so now let's put this into the Pythagorean theorem, which is, like I have up there in the corner, a squared plus b squared is equal to c squared. Okay, so let's just go ahead and call a x, so x squared plus x plus 7 squared, and then we have x plus 8 squared. Okay, buckle those seat belts because this one could get a little tricky. Okay, so we have x squared plus 7, or sorry, x plus 7 times x plus 7, because remember that's the whole entire base and we're writing it twice, x plus 8 times x plus 8. Okay, so I'm going to go off to the side here and do both of those in the area model just so you can visually see them. So let's start with this one first. I don't know why, I just don't go all the way down to the bottom. Okay. X and 7, x positive 7. So x squared, 7x, 7x, 49. Okay. Then I'm going to go ahead and do the other one just while I'm here, and then we're going to start writing everything that we have. Just go all the way down this time. Okay. X and 8, x and 8. X squared, 8x, 8x, and then 64. Okay, so let's write out everything that I just solved. So we have x squared plus, on the purple side, I have x squared. Hopefully you guys are okay with me combining those middle sections, doing 7 plus 7. And I'm going to go ahead and call that 14x plus 49. Okay, then on the pink part, on the other side of the equal sign, I have x squared. I'm going to go ahead and combine 8 and 8 and make that 16x plus 64. Okay, bear with me. There's a lot that's about to happen. Okay, something that I noticed is I'm going to move things from the 14x and 49 side. It's okay. I'm going to do it the other way, and we're just going to work with the negatives, okay? But you could move them in the opposite direction so you don't have negatives. So let's subtract x squared over. I'm going to go ahead and take it from this x squared. They happen to cancel there. Okay, subtract 16x. I'm going to go ahead and line this up with 16. And then subtract 64. And remember, I'm doing this so my equation is equal to 0. Okay, so when I do all of that, I have an x squared left. If I was to combine those, I would say 2x squared, then subtract 1 will still give me the 1x squared. Okay, 14 minus 16 is negative 2. And then 49 minus 64. I don't want to mess up during the video, so I'm going to do that in the calculator. Okay, and then that is negative 15. And then that is equal to 0. Okay, so you're able to factor this if you would like to. Set up your two parentheses. It looks like 3 and 5 is what's going to be working if you choose to factor, but I definitely want to make sure I dive into what the quadratic formula is just so we have more practice with that. Okay, and so that is negative b, so it would be 2 squared plus or minus radical negative 2 squared minus 4 times a times c all over 2 times 1. Okay, let's see if I remember this as we go on to the Desmos calculator. Okay, x is equal to negative, I already forgot, negative b parentheses, x equals to negative b plus or minus radical b squared, I'm going to have to put that in parentheses because it's a negative 2 squared minus 4 times minus 4 times a times c negative 15. Close my parentheses, divided by 2a. How did that get there? Okay, so we have 30. Be very, very careful about how you enter. I'm just going to start all the way over. How you enter in the calculator. So something that I see right here is that this particular Desmos calculator did not extend that, or the way I keyed it in did not extend that square root sign. Like, it did not extend over. Okay, so let's clear this. Okay, so x is equal to negative b plus or minus radical b squared minus, okay, it's going now, minus 4 times a times c, close my parentheses, and my radical sign went ahead and went all the way over, divided by 2a, which is 2. Okay, so we have 5. Let's just make sure that the other one, okay, 5 and negative 3. So we need to go with our positive because we're dealing with side lengths. And so a side length of the triangle has to be positive and not a negative. So x is equal to 5. Now let's dive into, found it. Okay, so x is equal to 5. Now let's dive in and find the other side lengths. Okay, so 5 is my shortest side down here. Okay, this side length would be 5 plus 7. Okay, and then we have 5 plus 8. So 13, 12, and 5 of your 3 side lengths. Okay.